Hello, welcome back. Today we're going to continue our discussion on volume of revolution. Today is going to be a little bit different as we are going to find the volume between, if we look down here, the volume between the area of two functions as we revolve it about an axis. Now, to start this, we're going to revisit a little bit of geometry. Back in geometry, we learned how to find the area between two concentric circles. So let's look at the image below. To get the area, well, we know the area of a circle is pi r squared. But if I only want to find the area of the blue region here, only the blue part, to do this, we would have to take this outside area and we would have to subtract this inside area. And that's what we do. We would take the outside area minus the inside area. Well, we're going to do exactly the same in terms of volume of revolution. Well, to get the area of the blue up here, well, the outside area would be the pi times the radius of the outside function minus pi squared minus pi times the radius of the inside function squared of the inside. So there's my radius of my inside, and there's the radius of our outside. And that would give us the area between the two circles, or the blue region right there. We're going to do the same skill when finding the volumes of revolution when there is a gap. This is called the washer method. So let's take a look at the following example. We want to try to find the volume between the function f of x and the function g of x. And we're going to revolve this about the x-axis. If we look at the image to the right, we kind of see what that image will create. It looks kind of like a vase right there. But the volume part that we want, the solid part, if you notice, is only the region that's being revolved between f of x and g of x. And if you notice, it's going to kind of form this little washer. That's why we call this a washer. A washer is just two circles with a hole, with a circle with a hole in it. And what we want to do is we want to find the volume of only the green part, or the shaded part here, I guess I should say, of the shaded part, to be more exact. So how do we do this? Well, just like in geometry, we are going to be looking at we have to look at the outside region, and we're going to subtract the inside region, except for in terms of area, we'll be talking about volumes. And that's exactly what we do here. How can we find the volume of the region between f and g? If we rotate about the x-axis, it's the following. Just like in geometry, the volume is going to be the volume of the outside disk minus the volume of the inside disk. Because if you notice, that's what we have this disk on the outside, and we have this disk on the inside. Now, what's the height of our disk? Well, we're in terms of x and we're vertical, so this is just going to be our dx right here. So we can actually kind of write this. To get the volume, remember volume yesterday was pi r squared h. Well, what we want to do is get pi. We want to get the radius of our outside. There's the radius of my outside right up here. Squared dx, because that's what h is, minus pi. The radius of my inside, sometimes called the radius of the hole, right here. And that's going to be pi radius of the inside function squared. Again, dx. And this is our little rule for today. And of course, we would integrate these. And this is going to be our form. Now, we can shortcut it a little bit. For example, I can take out the pi and the dx, because they're both going to be the same. And what I'm left with on the inside is the radius of the outside function squared minus the radius of the inside function squared. And then we would just integrate that from a to b. And there's a little rule for today. So it's really just here we have disk 1. This is the outer disk. And here we have the inner disk. So today we're just going to do the same thing we did yesterday with the volume of revolution, but we're going to have two disks this time. All right, so let's take a look at the graph below here. We want the graph to the right shows the function y equals x squared and y equals x, and hopefully we should be able to recognize them. There's our y equals x. Here is the red, the other one is y equals x squared. We want to know what would the volume be if we were to revolve the region about the x-axis. Now again, take a look here. We are saying we're revolving about the x-axis right there. So this is telling us we have to be in terms of x. And our rectangle of math will be vertical. So there's my x, here's my x-axis. I'm going to revolve around here. So just like yesterday, I need to draw or shade in my area that I want. And if we can do that, our area is going to be this little piece right in here. This is the area that's bounded between them. So we're only going to revolve this little region here around the x-axis. So I'm going to draw my rectangle of mathematics. But there's actually going to be two of them, really. You have this rectangle right here for the one function to the parabola, and then you have from the axis of revolution, we're measuring from the x-axis to the second function right here. So notice we have two disks. Now, so before we move on though, let's really redefine what a radius is. Remember, radius is the distance from the axis of revolution to the function. The only difference here we have actually two functions. So over here, this I have my outer. So this is my outer one. And for outer today. And this is our inner axis of radius right there. So what we're going to do is we wind up with two disks. So my first disk, I am looking at the inner part, just the part dealing with the parabola. Now, why do I call it the inner part? Because that's really the hole right there. If I want to, we can just call that the hole as well, or the hole. So if I draw that disk out, just like we did yesterday, there is my axis of revolution right there, and I can find my radius of that. Now I'm going to call that the radius of the inside. Well, what is the radius of the inside? Well, it's vertical, so it's going to be top minus bottom. The top is the parabola, y equals x squared. The bottom is 0. Now, you might remember yesterday, for the bottom, we said the bottom is always just the axis of revolution, which in this case is just the x-axis, or just 0 for us. So the radius here is x squared. The height is always just dx. Now, I'm going slow, but this goes really quickly. Now we got to do the other disk. Well, for the second disk, that's the disk on the outside. That is this disk, right? That is this disk right here. Remember, my rectangles of math, and there's my other disk. So if I draw that disk, same thing, I got to get my radius. In this case, we'll call it the radius of the outside. Because if I were to revolve it, take a look at it, I get one disk and two disks right there. To get this radius right here, again, same thing, we're vertical. So the outside is just y equals x, or the top is y equals x, and the bottom is just, again, my axis of revolution, or 0. So it's just going to be x minus 0, which is just x. So my height still, because it's vertical, is still dx. So now I correct my volume. Now we're not going to solve this one, we're just going to set up. So to get our volume, we're going to take the volume of the outer part minus the volume of the inner part. So to get the volume, that's just going to be pi, the outer radius, excuse me, is x squared dx minus the inside, pi, the inner radius, x squared dx. Very simple to do. And then just clean it all up. I can factor out the pi if I want to. You can even leave your answer like this, okay? You can leave it like this. So, matter of fact, let's go and do that. I'm going to get rid of this part. Let's get rid of that part. So I'm just going to integrate. But be careful, I'm going to have two antiderivatives right here. Now, the only thing I need now is to find out where they meet. This is the hard part. Where does x squared equal x? If I bring the x over, factor out an x, I just get x equals 0 and 1. So both of these would go from 0 to 1, 0 to 1. So there's my answer. There it is right there. Now I can leave it like this, or I can factor some things out. They both have a pi, and they both have this dx. So I can just write this as just x to the fourth. Whoops, sorry, that's an x squared, excuse me. The x squared minus, and this one becomes x to the fourth. And we would evaluate that from 0 to 1. And there's our answer. You can write it either way. Both ways would work. All right, so let's take a pause here. You can go to video 2, and I'll kind of show you a shortcut to do these, okay? And a little faster way to do them, okay? I'll see you then. Bye-bye.